So, in today's class, we'll be talking about functions in Python. And before we actually start, I like to give you a use case. So, a Python is, you can say, a named block of code which can be executed whenever we want in a program. It's usually used to modularize so that our code is easier to maintain. And like, for example, if a same piece of code is being executed from many places and you want to change the implementation, you can change the implementation at one place and it reflects everywhere else. So let us start with the help of an example. So I'll first open VS Code. Okay. So I'll rename. So let's say I call it example one. So imagine a scenario in which we want to do something many times in the program. Like say, for example, I'll keep it very simple. Let's say we want to say hello several times in a program. One way is you can write this line as many times as required. The other thing is, so the problem with writing it many times is like, say, for example, I actually copy it many times. Now, the problem with this approach is that, okay, it's working 4 times. If I run the program, it will say hello, hello, hello 4 times. But the issue is that if I have to change the message, let's say if I want to change hello into hi, then I have to go at those many places and change this hello into hi, which becomes tedious, right? So what we'll do is we'll create a function for the same. So in order to create a function in Python, we use the keyword def. Def stands for define, and let's say I call it greet. And then within this function, this is how we make a function: def followed by name of the function followed by an empty parenthesis if there are no parameters. Okay. Then what we'll do is we'll press enter and then we'll move this line over here. Okay, so what we'll do now is the function is defined, and in order to call that function, we'll just say greet followed by a parenthesis. So now if I run, obviously I'll get the same output, that is hell hi. But if I want to call it multiple times, I can call it multiple times. And if later on I want to change the message, I can simply go at one place and can change the message, and it will change at everywhere, at all the places. Is it making sense to everyone?
Yes, sir.
Okay. So this was a very simple case. Now let us say that along with the hello message, we want to give the name also. So now what we can do is we can pass an argument to a function. Like in this case, I want to say hello to a particular person. I can give a name over here. Let's say I say Vijay. So what we have to do, we have to pass it over here. So at this place, we call it as an argument. So Vijay in this case is an argument. And here we'll take a parameter which can be used within the function. Like say, for instance, I say that, okay, I'm taking a name. And then I'll say print. And then I say name. So now if I run this program again, it will just say hello followed by the name. And if you want to greet different persons in the program, we can simply copy paste it and then we can change the name, like say for example Vinay, or for that matter any other name, let's say Ajay. So if I run the program again, the function will be called and the value will be substituted. Any doubts in this?
No, sir. No,
No.
sir.
Okay, this is one.
No, sir.
Now this is something very, very simple. Now let us make it slightly more complex. So what we'll do is, the idea is not to make it complex, I want to show you more features. So let us say in this case only, I'm giving a name, but I want the functionality that if I don't say anything, no name should be given. Let's say I want that. So that is something known as an optional argument. Like say, for example, I can say over here that, okay, my default argument, default parameter is, let's give another name. Let's say Vipul, for example. Now what will happen is that if I'm giving the name, that name will be used. If I don't give any name, then whatever name has been supplied over here will be used. Like for example, I'll call this function once more. And this time I'm not giving any argument. Notice. Now when I run it, see, in the last output, it is saying Vipul. So this is something known as a default argument. You can give an argument which will be used when no argument is supplied. So if anyone has any doubts, they may ask now. No doubts?
None. Yeah.
No, sir.
Okay. So what we learned right now, we learned that this is a function call. This is a function definition. Name is equal to Whipple is a default parameter. Okay, this is one thing. Now let us move on to our second example. So we'll create another file, example2.py. And remember, once we did a program to reverse a number. Do you have memories of that? Okay, let us quickly do it again. So let's say I want to reverse a number. I want to write a program in which I want to reverse a number. And this time we'll first write the program normally, and then we'll rewrite it with a function. So what we did in the program, we asked the user to enter a number. So we'll do it again. We'll say int, and then we'll input it. We'll say input, and we'll say please enter an integer. So number is entered. Now we don't want to destroy the original number. So what we'll do, we'll say that, okay, num is equal to number. And then what we need to do, we need to take out one digit at a time, right? So in any digit extraction program, the common theme is you take a loop. While the number is more than 0, you take the loop, and within the loop, we'll take out a digit one at a time. We'll say digit is equal to num modulus 10. So one digit will come out. Then what we need to do, anyone?
Divided by 10. So yeah.
Yes, we have to reduce it. So divided by, we'll do integer division. So number is division divided by 10. We need to have a reverse variable also, since we need to reverse. So we'll say reverse is equal to 0 initially, and here we'll say that, okay, reverse is equal to reverse into 10 plus digit. So hopefully this should reverse the number. Let's check it out. I'll say print reverse. So now if I run this program and I enter a number, let's say 123, I press enter and it becomes 321. So the program is working. Now, those of you who are coming from other languages like Java and all, please understand, in Java, there is no difference in which order you make the functions. But here, a function must be made before it is called. So what we'll do, we'll go to the top and we'll define a function. We'll say define reverse number. And then we need an argument, and the function definition starts. Now we need to do the same thing which we are doing over here. So what we'll do now is that I'll copy this portion, I'll remove it from here, paste it over here, and then we'll give one tab so that it becomes a block. Now, once the answer is calculated, we don't want to print the answer. Please try to understand, whenever you are making a function, try to return the value so that whoever is calling the function can either use them in further calculation or print them. So what we'll do, we'll return the value. So we'll say return reverse over here. And if you go down, now there is no need to do this. We'll simply say print. We'll call the function and we'll say that, okay, reverse number, and we'll pass the number. So now if I run the program, again, it will ask us to enter a number. Let's say I say 123. I press enter and it gives us 321. Any doubts in this reversing logic?
No. Yeah.
No, sir.
Others, please go through it once and let me know if there is any issue before we make some more.
No, sir.
Okay, this is clear. So this is how you define a function. Okay. Now let us rename this to something more useful. So I'll say reverse. So I've stored this function in a file by the name of reverse.py. And let's say we want to do something similar, which requires this. Can you think of anything which requires this and is similar?
Palindrome check.
Exactly.
Perhaps.
Palindrome is a very good example. So what I'll do is, now we'll try to make a program which finds the palindrome of a number. And palindrome, as you know, is basically when a number is same as the reverse. Like, for example, if I say 121, if you reverse it, it becomes 121, and 121 equals 121, so it's a palindrome. I hope there is no doubt in the logic itself. So let's begin. So what I'll do is, I'll create another file. I'll call it palindrome.py. Done. And now you know that we have already done something similar. We have done that similar thing in the other file, which is reverse.py. And I want to use this over a palindrome. Now, there are two ways of going about it. First, we'll do the old way, or maybe the simpler way. I'll just copy this whole thing, place it in palindrome, and then I just make one more function over here. And let's call it is palindrome. We are trying to check whether or not it's a palindrome. And I say that, okay, I'll pass the number. And then we just need to check one thing, whether or not the reverse and the number are same. So if number is equal to reverse number of the same number, then we'll say return true. Else we'll say return false. And we'll make some more improvements in it. And we go down, and where we were printing reverse number, we'll just say print the number and tell whether it is a palindrome or not. So is palindrome, right? So if I run the program again and I enter the number 123, 123 is not a palindrome, so false. If I say 121, it says it is a palindrome, so true. Any doubts in this?
No. Yeah.
Now, if you notice carefully, there is a lot of redundant code. Like, for example, we are testing a condition. This condition will either be a true or it will be false. So if it is true, we are returning a true. If it is false, we are returning a false. So what we can do is, instead of writing all this, we can make it very small, and we can just say
Return num
is equal to reverse of number. The answer will still obviously be the same. So let's say I say 121 and it says true again. Now we'll also change it so that we give a nicer message. So what I'll do is I'll copy it over here, and then what we'll do, we'll say that if it is a palindrome, we'll give a more descriptive message over here. We'll say number is palindrome, else print number is not a palindrome. Also note, there is no need to give this leading space because Python will automatically give a separator. So now we'll get a much nicer output. So if I say 121, 121 is palindrome. Now, before I add more functionality, is it okay with everyone?
Yes, yeah.
Okay, now,
Yes, sir.
here what we are doing is that we have copied and pasted this function which we designed earlier. It was over here also. And the thing is, though this method is working, let's say if I change this function later on, then I have to copy paste it every time. So the better way is if we can use this reverse over here. So there is a way of doing it, and that is something known as a module. So what I can do is that I can remove this definition of reverse, and I can say over here, import reverse. So now in this case, what is happening is that there is a file reverse.py in the same location, so it will be found. And I'm saying import reverse. So everything which is here will come over here. And now you see this is not recognizing this reverse number. Why? Because it is not in this namespace. It is there in the reverse namespace. So I have to say over here reverse dot reverse number. Is that the name? REVERSE. Okay, so done. Now a strange thing will happen. Now you may think that, okay, computer will start the program for here, but actually the computer is not starting the program from here. Computer is importing this, and when it will import, it will run this. And the problem is now that when it will run this, it will take this also. Getting my point? So see, if I go and run this program, see what happens. If I run it, it is saying please enter an integer. If I say 121 and I press enter, see what happens. It is again asking, it has printed the reverse. It is again asking, and now this prompt is due to this. So now if I say 121 again, now it says 121 is a palindrome. So it is doing what we wanted it to do, but it is doing something extra also which we don't want. So can you think of any solution?
Remove it.
Exactly. That's the simplest possible thing. That if I remove these two lines, this problem will vanish. Let's say I comment it out for the time being, and we go back over here and we run the program again. So enter an integer 121. It says 121 is a palindrome. So now it seems to be working. But the problem is now if I directly go and run over here, there is nothing to run. It will start and finish. Right? So let's say we want both the functionalities. If you're okay with this, then it's okay. But let's say we want this functionality to exist, that if we want to run it directly, we should be able to run. Otherwise, it's okay. Make sense? So let's say I want to avoid running this code when this code is being running directly. But if it is being included in some other as a module, in some other program as a module, then I want this to avoid it. So what we'll do is first we'll put this in a function. We can call the function anyway, any name, but let's say I call it def main. It's more or less a tradition that the starting point or the entry function is known as a main, and then I move it like this. So now there's a function main, there's a function reverse number, but please understand if I run this directly, still nothing will happen. Why? Because no one is calling the main. So now if I run it, obviously it will start and it will finish. So now we'll see a very special thing. There is something defined by the name of __ main. And the interesting thing is that this is stored in a variable by the name of __ name __. This is something known as a dunder variable, double underscore variable. So here what is happening is that this is automatically defined by the Python interpreter. And if it is equal to main, it means that this file is being run directly. If it is not equal to main, then it means that this file is not being run directly. So here what we'll do is we'll just call main. Now try to understand, when I'll directly run this program, first this function will be defined, then the second function, that is the main, will be defined, and then the computer comes over here. Now, if this function is being called directly, name will be equal to main will be called, and these two lines will run. If it is not being called directly, nothing will happen. So like, for example, if you're including it from here, both the things will be included and this main will not be executed. So now if I run it from here, I say 123, it is saying that, okay, the reverse of 123 is 321. But if I go over here and I run it and I again enter 123, now this time it will simply say 123 is not a palindrome. So is it making sense to everyone, the whole idea?
Yep.
Uh-huh.
Anyone is having any
Yes, sir.
doubts, please let me know. So this is actually the real use case. You design something, in this case, the reverse number, you use that thing, you later want to reuse it in a different context. So we imported that file and we reused it. So if you want to ask anything, you may ask now.
That's pretty direct. Yeah.
Okay. I'll just call this one as intro because that is what it was. We'll give it a sensible name, intro.py. So if there are no questions, then I want to introduce one more topic today, one more subtopic
Sure.
today. Is everyone okay with this? What we are doing right now?
Yep.
Yes, sir.
Okay. So it is also possible to pass multiple arguments to a function. I'll show it with the help of an example. So let us say I have a file by the name of average.py. And this time we'll be writing, now since we know how it is to be done, we'll write all the programs in the proper way. So what I want to do is, I'll define a main function. And in the main function, I want to print the average of few numbers, and we'll define a function average for that purpose. Okay. So let's say I pass the two numbers as 3 and 4. So what I'm expecting to get 3 plus 4 divided by 2. Simple. So what I'll do is, and I want to call this function only when it's the main program. So I'll do that shortcut again, the dunder function main thing. And I'll say that, okay, call the main if it is called directly. Then we go to the top and we say def average. And we'll pass the two arguments. I'm keeping it simple. First, I'll pass the two arguments. Let's say the two arguments are A and B. So this is A comma B. We put a colon, we go down and we say that, okay, return the average. How do we find the average? We say return A plus B divided by 2. Is it okay?
Uh-huh.
Yep.
Yeah.
No, it is not okay. Please understand, this will divide B by 2 and then add it to A. This is not the average.
Yeah.
Average is A plus B divided by 2. Always please pay attention. Whenever I'm saying is it okay, probably something is not okay. That's why I'm asking.
Wrong.
Okay, so
Yeah.
this is done. So now if I run this program, notice it is saying 3.5, which is correct. 3.5 is in between 3 and 4. But let's say I want to find the average of 3 numbers, or 4 numbers, or 5 numbers. Now, theoretically, it is possible that I can overload this function for one variable, for 2 variable, 3 variable, 4 variable, but that will be too much of a work. So there is an alternative way, and that is we can have multiple arguments. So I'll leave this code over here. I have copied it, and then let's say I create one more thing. We call it avg.py, and within avg.py, what I'll do, I want to pass multiple arguments. So if you want to pass multiple arguments, you start it with asterisk. Okay, so let's say I just call it args, right? And just to show it to you that this is being called, what I'll do is, instead of returning it, now I'll simply say print args. So let's see what happens. You'll immediately notice what actually happens. So if I run it, see 3 and 4 are coming. Don't worry about this none. This is coming because nothing is being returned and I'm printing it, right? So you can ignore it for some time. So when I'm passing two things, it is saying 3 and 4. If I pass three things, let's say I copy this down and I say 3, 4. Let's say I pass one more, 5, 6. So now this function is being called twice. The first time it is called 3 and 4 is being passed. The next time it is being called 3, 4, 5, 6 is being passed, right? One more thing I would like you to notice is that this is not in box bracket. This is in parenthesis. The difference is that when you give it in box bracket, it is a list, and in list, list are mutable. You can modify the values. Here, this is being passed as a tuple, which means that these values are not mutable. but that is okay. We don't want to mutate them anyways. So we have got all the numbers, and now we want to find the average. So how do we find the average now? I'll remove this line. We need one variable for finding the sum. So we'll say sum is equal to 0. We need to iterate through all these values. So we use the for loop. We'll say for n in arc. So it will loop through them one by one. First 3, then 4. In the second case, first 3, then 4, then 5, then 6. And then what we need to do, we need to find the final sum. So sum plus is equal to, we'll say n. So when this loop is finished, we have the sum, and then we'll simply say return sum divided by what? Now we don't know divided by what. So what we'll do?
Args, not length. Len of args.
Len of arcs. So we'll say len of arcs, which will give us the length. So now if I run the program, so it prints 3.5 because the average of 3 and 4 is 3.5. And in the second case, it prints 4.5 because
Which is
3, 4,
correct.
5, 6. The middle value is 4.5. So making sense to everyone?
Yep.
So this is quite
sir.
straightforward, but see the whole part of it, that now we have a reusable part in which we can pass multiple arguments. So if there is any doubt, please let me know. Okay, there's
It
one
has
more
a very
good habit which you
C++,
can
symmetric.
have. You can have a docstring after the function name. So there are a lot of tools which will give you the help. So I can say over here, like for example, find the average of numbers. I'm just giving a simple example. So this is something known as a docstring. So this is just telling the Python interpreter that, okay, this is what this function is doing. So this is a good habit to have. Okay, so any doubts, let me know, or else I'll just include these programs in the classroom.
It has a very C++ symmetric syntax where you just define args.
Yeah, this is quite straightforward. Just like everything else in Python, they don't involve you with pointers and internal reference variable and all this stuff.
That looks like a pointer, by the way, because we use the exact same
No,
syntax.
that looks like a pointer. Technically, it is a reference variable internally, but the thing is that they are supposed to have something for that. So they choose something which is well known.
Okay, so that means if I give args with square brackets, that won't work to represent an array.
No, that is how you do know. There is no array in Python. Please understand that is a list. It's actually a full-blown object.
All right, okay.
So I believe that no one has any doubts now.
No, sir.
Okay then. So we'll keep it at this point of time, till this only, and tomorrow we'll see some more things. Okay, thank you.
Great, yeah. Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you, sir.
Thank you, sir.
Mm.